Hey everyone, and welcome. In the world of software, some of the absolute biggest battles are fought over the tiniest choices. And today, we're diving deep into one of the most fundamental decisions a programmer can make, one that happens literally millions of times a day in the apps running on your phone and computer right now.
On the surface, it seems so simple, right? You just need a list, a place to hold some items. Maybe it's a to-do list, a list of your contacts, a shopping list. It should be the easiest thing in the world. But what if I told you there's a deep, hidden complexity here?
Because, and this is no exaggeration, making the wrong choice here can lead to sluggish performance, frustrating lag, and an app that just feels broken. This single, seemingly simple decision can have massive consequences for the entire system.
And that brings us to this central mystery. Why is it that programming languages, like Java for instance, don't just give you one way to make a list? They give you two main options, the array list and the linked list. Why on earth would you have two different tools for what seems like the exact same job? Well, that's exactly what we're about to find out.
So let's meet our two contenders. In one corner, we have the orderly, rigid, and predictable array list. And in the other corner, we have the flexible, dynamic, chain-like linked list. They both get the job done, but as we're about to see, how they do it is what makes all the difference.
All right, let's start with our first suspect, the array list. Its name kind of gives away the secret, right? At its very core, it's built on a simple but really powerful data structure, an array.
I want you to picture a huge bookshelf where every single slot has a number, an index. If you need to grab the book in slot number 100, you don't have to start at slot 1 and count all the way up. Nope, you can go directly there, instantly. And that is the superpower of the array list.
In programmer speak, we call this random access. It means getting any element is blazing fast. Doesn't matter if it's the first one, the last one, or one buried deep in the middle. The time it takes is always the same.
But every superpower has its kryptonite. The array list's greatest strength, its rigid, orderly structure, is also its biggest weakness. So what happens if that bookshelf of ours is completely full and we need to add a brand new book right at the very beginning, in slot number 1?
Well, here's where we pay the price for all that order. You can't just squeeze the new book in. To make room, you literally have to take every single book on that shelf and shift it one spot over to the right. Now, if you have a list with millions of items, this shuffle is painfully, horribly slow.
So, that brings us to our second contender, which solves this exact problem with a totally different way of thinking. Meet the linked list. It throws rigid order out the window in exchange for ultimate flexibility.
A linked list isn't one big block like our bookshelf. Instead, I want you to imagine a scavenger hunt. You start at the first clue. That clue, we call it a node, holds an item, but it also holds the location of the next clue. So to get through the list, you have to follow this chain, one link at a time.
And this structure is just brilliant when it comes to making changes. You want to add a new item to the very beginning? No problem. You just create a new clue and tell it to point to the old beginning. You just changed one link in the chain. It is an incredibly fast operation no matter how long the list gets.
But here it is, the trade-off. Remember that scavenger hunt? If you want to find the 100th item, well, there are no shortcuts. You have to start at clue number 1 and painstakingly follow the chain through all 99 items that come before it. That random access superpower we loved in the array list is completely gone.
So we have one that's lightning fast for reading, and another that's a champion at adding stuff to the front. But how do we talk about these differences precisely? I mean, programmers need a way to measure and predict this kind of performance without running a million tests every single time.
The tool for the job is called algorithm analysis, and it comes with its own special shorthand, Big O notation. Now, I know it sounds super intimidating, but trust me, it's just a way of describing how an operation's performance changes as the amount of data gets bigger.
Let's just boil it down to the two most important types for our story today. First, you've got O of 1, or constant time. This just means an operation is always fast, no matter how huge the list gets. Think of grabbing an item from our array list bookshelf. Then you have O of n, or linear time. This means the bigger the list, the longer the operation takes in a straight line. Think of our linked list scavenger hunt.
And this chart right here shows you exactly why this distinction is so critical. See that O of 1 bar on the left? It stays low and flat, always fast. But that O of n bar, it just keeps climbing higher and higher as the list grows.
For really large data sets, this is literally the difference between an app that feels instant and one that is completely unusable.
Okay, so now we have the concepts, and we have the language to analyze our two contenders. It is time. Let's bring it all together and finally solve the mystery of why they both exist. It's time for the verdict.
And this table just lays out the trade-offs perfectly. It's so clear. If you're going to be getting items by their position all the time, ArrayList's O of 1 constant time is the obvious winner. But if your main job is adding and removing things from the start of the list, linked list's O of 1 speed is just unbeatable. You see? Each one is a rock star where the other one stumbles. And this leads us to the fundamental truth of it all. There is no such thing as a best list. The right choice is all about understanding the job you need to do. Are you mostly reading from the list, or are you constantly changing it? The problem dictates the tool you should use.
But this raises an even bigger, more interesting question. What if you're not sure which one is right at the beginning? Or what if the needs of your app change over time? Are you just locked into your first choice forever? Well, this is where a truly beautiful idea in software design comes into play.
The solution is to not tie yourself to an array list or a linked list specifically. Instead, you program to the general idea of a list. And this powerful concept is called programming to an interface.
And this is just brilliant. It means your code is written to depend on the rules of a list, that it can add an item or get an item, not the nitty-gritty details of how it does it. This gives you amazing flexibility. You can start your app with an array list, and then later, if you realize a linked list would actually be faster, you can make that switch by changing just one single line of code without having to rewrite your entire application.
So the next time you're using an app and it hangs for just a split second when you're adding something to a long list, maybe you'll wonder, did the designers choose an array list when they probably should have used a linked list? It's these invisible decisions, these fundamental trade-offs that are shaping the digital world we use every single day.